Welcome back to my YouTube channel. In the course of this video lesson, I'll be solving different practice questions that cut across different topics in chemistry. Now let's get into the first practice question, and it says, what is the formula of sodium gallate? Listen carefully, all right? If gallium with this chemical symbol Ga shows an oxidation number of +3. Now, this question is extremely very easy. Before solving this question, it is important for me to interpret what this question actually says. It is very, very important, so listen carefully. I read the question again. The question says, what is the formula of sodium gallate? Sodium gallate is a compound. Are you there? If gallium with this chemical symbol Ga shows an oxidation number of +3. So what they are actually asking us to look out for, because all of these are compounds, any of them here can be sodium gallate. I don't know yet. At the end of solving this question, we will now know specifically the one that is sodium gallate in this option. Are you there? And how do we know the one that is sodium gallate? We have to check. We have to check specifically for gallium to actually know the compound to which the oxidation number of gallium will be +3 as shown in the question. So you can see I just mentioned a word in this particular question, and that aspect of chemistry is called oxidation number. It is important for you to understand perfectly the concept of oxidation number. So before me solving this question, we have to know some key points about oxidation number, and I'll be doing the explanation here. So after explaining everything you need to know about oxidation number, we then move further to solve this question. It is very, very easy. So watch closely. Now, this must be noted. You must understand here that all elements in chemistry have their respective oxidation number. Are you there? Let's take, for instance, this is option A with this chemical formula. It is a compound. I don't know specifically if this compound is sodium gallate. I'm going to solve it so that you see specifically how it is done. I don't want to rush the question. I want to take it step by step. So what I'm trying to say here is that all elements in chemistry have their oxidation number. Like sodium is one part of this compound. It has its own oxidation number. Gallium, Ga, is another part of this compound. It has its own oxidation number. And lastly, oxygen has its own oxidation number as well. So all elements have their respective oxidation number. So what I want to learn here is how to determine this oxidation number in these elements, how to calculate this oxidation number of these elements in all of these options. So there are some key things you must note before you start solving the oxidation number of elements in a compound. So watch closely. So point 1, listen carefully. You must note here that the oxidation number, I'll be using ON, oxidation number, are you there? The oxidation number, first point, of a free element, the oxidation number of a free element, this must be noted. The oxidation number of a free element is always equal to 0. So take note, the oxidation number of a free element is always equal to 0. Now this is what I mean, because you have to understand perfectly what a free element actually is. A free element is an element that is uncombined. A free element is an element that is standing alone. Just that element, nothing is attached. So this is what I mean. Let's take oxygen as an example. You know, oxygen is written, molecularly as O2. Are you there? It's very simple. So oxygen. So they cannot ask you, what is the oxidation number of oxygen you are looking at right now? What will you say? You simply say it is 0. Why? because it is uncombined, because it is without anything, because it's standing alone. Are you there? So taking another element like nitrogen, N2, what becomes the oxidation number is still going to be 0. Are you there? It's not because it's 2 2. No. If the element is standing alone, the oxidation number should be 0. Let's take another element like sulfur. Sulfur molecularly is written as S8. Are you there? There are some things you should just note. So just take note, the element is standing alone. So what becomes the oxidation number? The oxidation number should be what? 0. I believe you are following me. Let's take another example like chlorine, Cl2. What becomes the oxidation number of this element as well? So comment down the answer to this particular question just asked. When the element is uncombined, when the element is free, when the element is standing alone, the oxidation number should be what? 0. I believe you are following. This is the first point you should take note of on the oxidation number, because there are some other things I'm going to tell you in this video so that when solving this question, it will be very easy. Are you following me? It is very cheap. It is not difficult. So let's get into another point on this oxidation number. So we'll talk about this one. So let's progress. Now this must be noted as well. The oxidation number ON of a simple ion, all right, I'm going to explain what I mean by this. Whenever you hear the word ion, an ion is simply a charged atom. Are you there? Let's take, all right, before we continue, let me just tell you what we should note here. The oxidation number of a simple ion is simply the charge. Take notes, it's very simple. It's simply the charge of the ion. All right, the charge of the ion, or the charge on the ion. Now, this is what I mean. Let's take an example. This is sodium, Na+1. Are you there? Sodium is an ion. What is an ion? An ion is simply a charged atom. This word ion can be of two kinds. We have ions that are positive, ions that are negative. Those ions that are positively charged, we call them cations. Those ions that are negatively charged, we call them anions. Are you there? So this sodium, Na+1, what will you call it? It's the cation. So what becomes the oxidation number of this sodium we are looking at? It is simply the charge on the ion. What is the charge on the ion? It is +1. You have to be specific. It is +1. So then the oxidation number of Na+1 should be +1. Are you there? Let's take another example like calcium 2+. What becomes the oxidation number? It is very simple. Comment down in the comment section. Are you there? Let's go for negatively charged elements. Sulfur 2-. This is also another ion, but now it is negatively charged, hence it's going to be an anion. So what becomes the oxidation number here? I believe you know the answer to this question. It is simply the charge on the ion. Are you there? So all of these things I'm saying will help us here to solve this question, all right? So you have to listen carefully. Make sure you comment the answers to all of these questions I'm asking. It is very important to engage you, to prepare your mind in solving this question. Are you there? It's very simple. So moving further, let's get into other points on this aspect, all right? So moving further, we must also know here that the oxidation number of an element, which is very popular, which is very common, of oxygen, all right, of oxygen in most states, of oxygen in most compounds, let's use that word, of oxygen in most compounds is equal to
-2.
Are you there? So if they ask you what's the oxidation number of oxygen in most compounds, so please don't get this wrong. You can see that oxygen is present in a compound now. That is why the oxidation number was not 0. Before we talked about oxygen standing alone, the oxidation number is 0. Any element standing alone, the oxidation number is 0. But now oxygen is in a compound. Are you there? So what becomes the oxidation number of oxygen? -2. Are you there? Please, this thing is very important. The reason I had to single out just oxygen, because oxygen is present in most compounds. You can see in this compound given to us, oxygen is there. You can see in even this reaction in question 2, oxygen is there as well. So it's important for you to know the oxidation number of oxygen in most compounds, and it is -2. But the oxidation number of oxygen in a very special types of compounds called peroxides, the oxidation number of oxygen is actually -1 there. Are you there? But we are not talking about peroxides here. If I was to talk about peroxide or stress on that aspect, I'm going to stress on it. But just note what I just said. The oxidation number of oxygen in peroxides is -1, because that question can just come as an objective question in your JAMB exam, so you should note that. Are you there? So moving further, let's go over to another point. The oxidation number of hydrogen as well, because oxygen and hydrogen are very common in compounds, of hydrogen in most compounds as well. You can see that the hydrogen is not standing alone. You can see that the hydrogen is in a compound. In most compounds, this one now is +1. Are you there? Please listen carefully. It's very simple. All right. So let's get into other points on oxidation number determination before we go here to solve this question, and they're all very easy. So let's get into the next point. All right. So the next point here is the oxidation number, all right, of halogens. What are halogens? Halogens are groups of compounds. They are part of the periodic table. We call them the salt formers. Are you there? They like forming salts, and they are basically group 7 elements. Are you there? In the periodic table. So the oxidation number of halogens in most compounds is simply, please take note, in most compounds is simply -1. Please listen carefully. This is very important. For halogen in most compounds, halogens include, fluorine, chlorine, bromine, iodine, astatine, tennessine. So all these must be noted. So let's get into the last 2 points under oxidation number determination before we move straight into this question, because we need all of this knowledge to tackle this question. So let's get into the other points you should note on oxidation number determination, because it was mentioned in the question. It's not just good for me to just solve the question straight. It is important for you to understand the rudiments. So let us progress. Now, this is very important. I'm not going to write much. I'm just going to say it with my mouth, and then I will explain. Take note of this. Now, point next. The algebraic sum of all the oxidation number of elements in a compound is equal to 0. Now, this is what I mean. It's very simple. Watch. This is a compound, for instance. A compound is like this guy, H2SO4 is a compound, all right? Sodium hydroxide is a compound. HCl is all of these, any compound at all. These things are compounds, all right? So the algebraic sum of the oxidation number of all elements in a compound, all elements in a compound is equal to 0. So if they now ask you, what's your algebraic sum of the oxidation number of all the elements here, what will you say? It is 0. You always equate it to 0. What will you say is the algebraic sum of all the oxidation number of elements here? What will you say? 0. Are you there? Same applies to this other one. What is the algebraic sum of all the oxidation number in this compound, of elements in this compound? What will you say elsewhere? It is 0. Are you there? So I believe you understand what was explained in this point. So let's get into the last point you should note on this aspect, all right? But now we will not be using compound, we'll be using what we call radicals. A good example of a radical is this substance I'm writing here, which is SO4 2 minus. It is a radical. What are radicals? Radicals are groups of atoms, many elements coming together, and they are held together by a charge. They are held together by what? A charge. The charge can be either positive or negative. You can see all these elements are held together by this charge. So we call these radicals. So this is a radical. And what is the algebraic sum of the oxidation number of all elements in a radical? Is simply equal to the charge on the radical. So what will you say here? So you simply rewrite this to be SO4 is equal to -2. Are you there? Because the algebraic sum of the oxidation number in this radical is equal to the charge. Do you understand? That's how it was solved. It's very simple. Now work this out. So what's the algebraic sum of the oxidation number in this radical CO3 2 minus. You do for this, what becomes this other one? NH4 plus, this ammonium radical, 4 plus 1 to be specific. So tell me the algebraic sum of the oxidation number of this other radical. Is very simple. So let's get straight into the question. So we can use all of this knowledge we've gotten to tackle the question and determine the compound to which the oxidation number of gallium Ga will be +3. So we have to start calculating from the first option. This concept of oxidation number is simply calculations, little calculation, and it's very simple. So let's move straight into analyzing each of the options. So let's go straight into analyzing each of the options. This is option A. I'm going to write it out here, which is Na, all right, Ga, all right, O3. Now, this question is extremely very easy. Listen carefully. So, you can see we are interested in what elements in all of this option. We are interested in, understanding how gallium is in all of the compound. So, I've underlined gallium Ga here. So, what we are trying to do here is simply to calculate the oxidation number of gallium in this compound. I believe you just saw sodium, because in all my explanation, I did not talk about sodium, all right? But it's simple. Listen carefully. Sodium is a group 1 element of the periodic table, and all elements in group 1, they have their oxidation number to be +1. Do you understand? So you have to know the first 20 elements, because these are the questions, these are the elements that they can actually go over to ask you for. Do you understand? So note this now. All elements in group 1, they have +1 charge. All elements in group 2 have +2 charge. All elements in group 3 have +3 charge. All elements in group 7 has -1 charge. So these are the ones that are almost or always constant, all right? So you can say, I just stopped here. There are other groups, but these I just mentioned is very, very important, because these are the common elements they do ask. That's what I had to tell you. The periodic table will be on the screen, so you see what I'm talking about specifically. So any element you are seeing in that group, you simply just know the charge to be +1, +2, +3, -1, as seen in group 7. Are you there? So let's go straight into solving this question. What did I say? First of all, when we analyze, because this is a compound now, so what becomes the algebraic sum of the oxidation number in a compound? What did I tell you? I told you it is 0. I told you that. All right, I told you that the algebraic sum of all the oxidation number in a compound is 0. So the first thing I do is to equate that compound to 0. Do you understand? If it was a radical, it's going to be equal to the charge on the radical. So we are looking for gallium. So what did I tell you is the oxidation number of sodium? I told you that the oxidation number is +1. So on sodium, I'm going to write +1. It's very simple. So I've analyzed sodium. On sodium, what did I write? +1. So now, as soon as I'm done with a particular element, to go over to the element, I simply write plus, note that. So after sodium, I write plus. Do you understand? And we're looking for gallium specifically. I'm going to rewrite gallium Ga. This is the unknown element. Are you there? So since I'm done with a particular element, what did I tell you, right? You still write what? Plus again. Plus. All right, oxygen now. What did I tell you is the oxidation number of oxygen in most compound? I told you it is -2. So when I see oxygen, I'm going to write -2. Do you understand? It's very simple. So after I've written -2 for oxygen, now how many oxygen can you see in this compound? You can see 3 oxygen. So those elements in front of those those numbers rather in front of these elements, when you see a number in front of an element, you times it, you times that number. So it's going to be -2 times 3. Do you understand? I believe you are following. It's very simple. You can see how we analyze all of them. Is equal to the same number, 0. Are you there? So because this one has times, I don't want you to get confused. Simply put it in a bracket. Are you there? Which I just did. So let's further break it down. It's going to be still +1 plus gallium, which we are looking for. Now, plus, bracket means times. So plus times minus is actually minus. Plus times plus is plus. Minus times minus is plus. But plus times minus is minus. Do you understand? Let me make it clear very well. Plus times minus is equal to minus. Plus times minus. Plus times minus is minus. For instance, we had minus times minus. What was that? It is plus. Are you there? If it was plus times plus, it is still plus. But minus times minus is plus. Do you understand? It's very simple. So here, what will I write? Minus 2 times 3 was that 6. All right, 2 times 3 is 6 is equal to what? 0. Let's further break it down. So what will happen next is for us to now move. All right, it's going to cross the equality sign. So when minus 6 cross the equality sign, is going to be plus 6. All right, when plus 1 crosses, all right, when this plus 1 crosses, what are we having? Is going to be minus 1. So in all, we're having gallium is equal to 0 remains, all right, plus 6 minus 1. So gallium will be what now? Plus 6. All right, you have to be specific about the number so you don't make any mistake. Plus 6 minus 1, what becomes it? Gallium will now be what now? Plus 5. All right, you have 6 naira, you are owing someone 1 naira, so definitely after paying you are getting 5 naira, so that's why it's positive. All right, so you can see that the oxidation number of gallium in option A was plus 5. It does not correspond to what they told us. We have to make sure we solve so that we can get plus, plus 3, and we got plus 5. So option A is wrong. So let's go over to option B and analyze. So let's go straight into the next option. Let's analyze the next option and try to determine the oxidation number of gallium. This is the next option, option B, and the option is actually Na2, all right, Ga, which we are looking for the oxidation number, open bracket, OH, close bracket 2. You can see this compound written on the board. I believe you can see here that this compound has a bracket. So I have to tell you something that is very important so you don't stress yourself. Whenever you see a compound with a bracket, try to simplify that compound so that it will be easy for you. And before we do all of these things, we have to actually follow the rule I told you. Whenever you say compound, what becomes the algebraic sum of the oxidation number in that compound is actually equal to 0. But we know we are rewriting this, so let us rewrite before we calculate the oxidation number of all the gallium. So rewriting it is going to be what? The 2 outside the bracket will times everything inside the bracket. Will not times everything outside the bracket. Times everything inside the bracket. So when we do that, we are having Na2 remains the same. Gallium remains the same because that's what we're looking for. 2 here times in everything inside the bracket. So 2 times oxygen is going to be O2. 2 times hydrogen is going to be H2 is equal to 0. Do you understand? It's very simple. So let's calculate for the oxidation number of gallium. It's very simple. Watch closely. So as earlier said, the first element here is sodium. And what did I tell you is the oxidation number of sodium in most compounds. Sodium all the time is simply plus 1. Take note of that because you might see another question that has sodium in it, so you don't have to forget it. Sodium is plus 1 all the time. All elements in group 1 is plus 1 for their oxidation number. And sodium is part of them. And now you can see that we have 2 of this sodium, 2 of the sodium, so it's going to be what now? 1 plus 1 times 2. Do you understand? Because we have 2 of it. So to go to another element, what do you write? Plus. Gallium is what we're looking for, remains the same. Gallium, unknown. We are done with gallium. To go over to oxygen, plus. Oxygen oxidation number in most compound, as earlier said, is simply minus 2. Are you there? And now, how many oxygen do we have? We have 2 oxygen, in this part. So it's going to be minus 2 times 2. Do you understand? So since I'm just seeing minus, I don't have to get confused. I'm going to put this in a bracket. Do you understand? So moving further to the next element, which is for hydrogen. And before we go to hydrogen, we simply write plus. And now, what's the oxidation number of hydrogen? I told you initially in most compounds, I told you oxidation number of hydrogen is plus 1. I told you. So then it's going to still be plus 1. And how many of the hydrogen do we have? We have 2 of it. So plus 1 times 2. Do you understand? So since I'm having 2 signs here, put it in the bracket so you don't get confused. Do you understand what I'm doing? So we create everything to be 0 as seen here. So moving further, what we do, we have to break everything down. So let's break everything down. It's going to be plus 1 times 2. That's plus 2. I believe you understand. 1 times 2, 2. So plus 3 remains. All right. Plus gallium, which is unknown. Here becomes plus, but here is minus 2 times 2. 2 times 2 is 4, that's minus 4. All right. And we already know that plus minus plus minus plus minus plus minus minus, so everything becomes minus 4. Do you understand? It's very simple. All right. So moving further, plus 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 is still plus. Plus times plus is plus, and we have 1 times 2 inside the bracket, so it's still 2. So everything becomes plus 2 equal to what? 0. So what do we do next? Very simple. We are going to write something like plus 2 again, plus gallium, minus 4 plus 2, minus 4 plus 2. You are owing somebody 4 naira, you have 2 naira. When you pay the 2 naira, how much are you still owing the person? You are still owing the person 2 naira, so then it's still going to be minus 2. Do you understand? It's equal to 0. All right, so we are looking for gallium. So what do? All these things moves. So when minus 2 crosses the equality sign, it becomes plus 2. When plus 2 crosses the equality sign, it becomes minus 2. So gallium becomes 0 plus 2 minus 2 plus 2 minus 2. Do you understand? So gallium will now be equal to what now? Plus 2 and minus 2. So 2 minus 2, that's what this thing says. You have 2 naira, you are owing somebody 2 naira. So then when you pay that person the 2 naira, only how much will be left for you is 0 naira. So the oxidation number of gallium, because this is still like say 2 minus 2 is 0. Do you understand? So you simply say that the oxidation number of gallium in this compound is 0, and that is not what they told us. They told us that when we calculate for the oxidation number of gallium, we have to get plus 3. So option B is still wrong. Do you understand? So let's get straight into option C. All right, to analyze and see if the oxidation number of gallium is plus 3. So let's get straight into the option C and see if the oxidation number of gallium should be plus 3 and the compound is NaGa, all right, open bracket OH, close bracket 4. So let's carefully calculate for the oxidation number of gallium. Remember, it's a compound, you have to equate everything is equal to 0. I believe you understand that. So moving further, sodium oxidation number is plus 1, does not change. It still remains the same. Plus gallium remains gallium, which we are looking for. Remember, what did I tell you? Before you actually do all of these things, make sure that you are writing the compound in a way that you understand and won't be hard. Though I can solve like this, but it's important, since you are just coming up, it's very important for you to understand it step by step. So let's take it again. So rewriting this is going to be NaGa, 4 times O4, 4 times H4 is equal to 0. Do you understand? It's very simple. So sodium oxidation number is plus 1, plus gallium, which we are looking for, gallium. Do you understand? So it still remains the same. Plus oxygen oxidation number in most states is minus 2. I told you already, and we have 4 of it. So minus 2 times 4. Do you understand? So what do we write next? Plus hydrogen. Hydrogen oxidation number in most states is plus 1. I told you. So plus 1 for hydrogen times what? 4, because we have 4 of it is equal to 0. So put this in a bracket, put this in a bracket as well. So plus 1 plus gallium or minus 8. You understand now? You understand how this is minus 8? 2 times 4 is 8. Minus plus times minus is minus. Do you understand? Plus, 1 times 4 is 4, and this is plus is still 4, so plus 4 is equal to 0. So what happens next is going to be plus 1, yes, plus Ga. You are owing somebody 8 naira, you have 4 naira. So when you pay that 4 naira, how much are you owing the person? You are owing the person 4 naira, so it's going to be minus 4. Minus 8 plus 4. Do you understand what's happening now? Minus 8 plus 4 is minus 4, is equal to 0. So what happens next? This minus 4 crosses to become positive 4 rather. This plus 1 crosses to become negative 1. So what are we having? Gallium will not be what? Ga will not be equal to what now? 0 plus 4 minus 1. So Ga will not be equal to plus 4 minus 1. Alright, so 4 minus 1, that's what they are saying. 4 minus 1 is actually what now? Plus 3. So you have to be specific. So you can see we've gotten the answer to the question. So you can see that when we solve for the oxidation number of option C, we had the oxidation number of gallium to be plus 3. So option C is the answer to this question. It is very simple. If you solve for option D, you won't get plus 3, you get something else. I believe you understand the rudiment to which oxidation number is being calculated for elements in a compound. Is very simple. So your own task for me is to calculate for the oxidation number of gallium here and tell me the answer. So here are your own take-home assignments on this question 1. So you calculate for the oxidation number of sulfur in the following compounds. All right, you are calculating for sulfur in this H2SO4. You are calculating for sulfur. You are calculating for sulfur in H2S. It's simple. You are calculating for sulfur in SO4 2 minus. All of them are simple. Do you understand what I'm doing? You are calculating for calcium in CaO because I've given you all what you need. Do you understand? It's very simple. So all of these are your assignments, including this. So solve the question and put the answers in the comment section. If you find my video lessons helpful, make sure you click on the subscribe button to my channel and also share my videos to friends. Make sure you click on the subscribe button. I know this particular video right now will get to thousands of views, and as we are getting thousands of views, we should be getting thousands and more thousands of subscribers. Make sure you share these lessons with your friends because it will help you guys improve. So I'm waiting for you to subscribe. Before I progress to question 2, make sure you click on the subscribe button and as well share the link of this video to your friends. All right, so I'm waiting. So do that before we progress. All right, so let's go straight into question 2 and analyze question 2. I had to actually arrange this question first before this because we need the knowledge of what we just said to analyze this question, and it is very, very simple. So stay tuned. So let's get into the next question.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAMB exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.
So let's get into question 2, and question 2 says, all right, they gave us a reaction. And what does the question say? It says, which of the substance, just listen, serves as an oxidizing agent? It's very simple. Before I even explain what an oxidizing agent is, I have to tell you something very, very important. You know, in a reaction, in reactions in chemistry, we have 2 types of agents present in a reaction, and they are the oxidizing agent and as well as reducing agent. Now, this is the trick you must just know. You don't have to stress yourself. Oxidizing agent and reducing agent in a reaction is found at the reactant side. It's always found at the left-hand side of a reaction. Are you following me? So the answer to this question is going to be either the guys that are found in the left. But now listen carefully. This reaction you're looking at specifically is a redox reaction. What is a redox reaction? A redox reaction is simply a reaction in which reduction and oxidation occur simultaneously. From the word redox, I can bring 2 types of reaction. Red means reduction, and ox here means oxidation. So a redox reaction is a reaction in which these 2 processes are occurring together. They are occurring simultaneously. Do you understand? So, and I just mentioned that in this reaction is a redox reaction. For you to get the oxidizing and reducing agent, they are both found in the left hand side. Now, in some reactions, like in this redox reaction, I believe you can see this hydrogen ion, which is H+. You know, whenever you see hydrogen, H+ is simply pronounced as hydrogen ion. Please note this. The H+ that is written here is not the oxidizing or reducing agent. So the oxidizing or reducing agent is going to be between these 2 guys. Do you understand? Because this H+, which is called hydrogen ion, was just here to balance the reaction. We don't need it. So in other reactions or other questions you have to solve and you see H+, leave that H+ alone and focus on the 2 remaining guys. We have other reactions where H+ will not be written. So it's just 2 reactants alone. So you focus on those 2 reactants and try to determine which one is oxidizing and reducing, which I will be teaching you in this question. I believe you understand. H+ is not used, it's just used to balance the reaction. It's telling us that the reaction is actually balanced. Do you understand? So that is for that. So let's get straight into determining which one is reducing and which one is the oxidizing agent. It is very simple. Now, let me go straight to tell you what oxidizing agent is and also reducing agent. In this question, they just ask for oxidizing agent. But it is important for me to tell you both oxidizing and reducing agent. What is an oxidizing agent? An oxidizing agent is a substance. Which of these substances? So it's a substance or a species that undergoes reduction. Do you understand? So when that substance undergoes reduction, what is it called? It is an oxidizing agent, like opposite. When you undergo reduction, you are oxidizing agent. But when that substance undergoes oxidation, you are a reducing agent. Do you understand what I'm saying? It's very simple. So I have to now teach you how to know the substance that undergoes reduction and oxidation. Because I believe you know that the ones that undergo reduction is oxidizing agent. The one that undergoes oxidation is reducing agent. And we have different terms to actually define reduction and oxidation. But in the course of this question, and because of what we just did, the first question we solved, we stress on oxidation number. I'll be using oxidation number to define reduction and oxidation for you. It's simple. Reduction, oxidation, I'll be using oxidation number to actually define it. Oxidation number, I'll be using this to define reduction and oxidation. All right. So I'll start with oxidation. For oxidation number, based on oxidation number, is simply increase in oxidation number. What did I say? Oxidation is what? Increase in oxidation number. What becomes reduction? Opposite, it is decrease in oxidation number. Do you understand what I just said? It's very important. We have other terminologies to define this, but in the course of this question and more subsequent videos to be out on my videos, I'm going to explain for other terminology. But if you know this, you can answer any question based on this aspect, determining reducing and oxidizing agent. They are very, very simple. So let's get straight to analyze this question. So what do we do next? Very simple. Remember I told you that this, we don't need it here. And I'm still going to tell you something. The numbers, all of these numbers were just here to balance the reaction. We don't need these numbers as well to determine reducing and oxidizing agent. We just need what is happening. Do you understand? So this how it works. This how it works. You relate what is found at your left, with the exception of this guy now. Because in some other reaction, they just give you two reactants and your products. And I'm still going to tell you something. It's very simple. So just listen carefully. You relate what you have in your left with what you have in your right, in terms of what is common between them. Listen. In this first substance, this is MnO. Now let me write it out. This is MnO4 minus, right? All right. I said you don't need the numbers, just the substance itself. There are two of them. I'm going to bring them out. And this is Cl minus, right? Yes. So now relating these two guys with these other guys. Now you can see that chlorine should actually have business with this other guy. You actually look for if an element is found here, try to look for the product side, the same element or something that element is in, and bring it out and relate them together. So you can see that chlorine Cl minus should be relating with this other guy. Do you understand what's happening? It's simple. It's simple. Listen carefully. So MnO4 minus. Now observe. Okay, I have MnO4 minus here. So here there's Mn. And I told you that these two guys are what we need. There's Mn here. So wow, that means I'm actually relating it to this Mn, Mn2 plus. Do you understand? I cannot relate this with this. Do you understand what I'm saying? That I can't relate it. The reason I had to bring this particular question, I want you to understand it very well. There's another question whereby it's just two we're having here, two at our product, then is going to be just relating that to, but I have to make sure that it's three substances, so that so you see what I'm talking about. So actually this guy and this guy were the one that were to relate, so that we have to relate together initially, but I told you we don't use it. Do you understand? So it's important for you to know that it is MnO4 minus and this Mn we're actually relating together, and chlorine. This one is very clear now, it's very lucid. Are you not seeing chlorine? What are you to relate that this Cl minus to? It's definitely his brother. Do you understand? And we now have to understand what is occurring between them to know what we've said already, and then to analyze the question. So just have this in mind that this is related to this. Get it straight. I'm going to give you more practice question to understand it. It's very simple. So it's basically like, just going in a particular order, whereby this, and this, and this. And you know that we're not using the, whenever you see H plus, leave that alone, don't need it. And I'm still going to give you reactions with that H plus, and you tell me the one that is using oxidizing, that they are very simple. All right. So moving further, what's occurring here? We simply need to calculate the oxidation number of Mn. in this, radical. This is a radical of Mn in this radical. It's simple. Just watch closely. So this is what I do. I bring it out again. MnO4 minus. And I told you we'll write it as MnO4 minus means minus 1. When they just tell you minus, it means that there is a minus 1 specifically, so minus 1. So you can see we equated everything to minus 1. I believe you are following me. So if you want to be specific, they can write minus 2. Whenever you see minus, it means minus 1. I believe you are following me. So what next should happen here? What next should happen here is going to be, we are looking for Mn is unknown. Now, what is the oxidation number of oxygen in most compound? I told you it is minus 2. So normally after writing an element, you say plus minus 2, and we have 4 times 4 is equal to minus 1. I believe you are following. Is very simple. So what should happen next is going to be Mn, plus minus, that is minus, all right. 2 times 4, that is 8. So minus 8 is equal to minus 1. Do you understand? So Mn will not be equal to what now? When 8 crosses, it becomes positive 8. Do you understand? So positive 8. So it's going to be what now? Minus equal to minus 1 plus 8. So Mn will be equal to what now? Plus 7. Do you understand what's happening? So you can see that we've calculated the oxidation number of what now? Of manganese. It's not magnesium. Manganese in this compound, and it's plus 7. So you can see that manganese is moving from plus 7 to what? Since this is an ion standing alone, what's the oxidation number here? It is plus 2. Since I told you already now, one of the steps are whenever you see an ion, the charge on the ion is simply the oxidation number of that substance. So the oxidation number here is plus 2. Do you understand? So you can see that manganese is moving from plus 7 to plus 2. What's happening there? Is that a reduction? All right, let me not use that word. Is that a decrease in oxidation number? Yes, it is a decrease in oxidation number. Automatically, it becomes reduction. But we have to check for this what's occurring here to know exactly what we're doing, to know exactly what we just said is correct. It's simple. Watch closely. So you can see here that manganese is moving from plus 7 to plus 2. That's a decrease. But let's check for chlorine. Chloride is not, whenever chlorine has a charge, it's pronounced as chloride. So here now, it's just minus signifies minus 1. I told you already. Whenever you see minus, just minus 1. Whenever you see just plus 1. So this chlorine is moving, chloride rather, is moving from minus 1 to, this an element standing alone. I told you the oxidation number is 0, right? So you can see that it's going from minus 1 to 0. Minus 1 to 0, what's that? Is that an increase or a decrease? You know that 0 is even bigger than this. This is more smaller in the number line system, all right? It's going from minus 0, 1, 2, 3 like that. Do you understand what I'm saying now? So you can see that this is from minus 1 to 0 is an increase in oxidation number. So when there is an increase in oxidation number, I told you is oxidation. When there is a decrease, is reduction. Do you understand? So you can see the manganese here undergoes reduction. Manganese Mn undergoes what? Reduction. Whereby chlorine Cl undergoes oxidation. Do you understand? It's simple, because in the chlorine relationship there was an increase, so it's oxidation. In this one there was a decrease, that's reduction. And I told you the ones that undergoes reduction, they are the oxidizing agent, whereby the ones that will undergo oxidation, they are the reducing agent. So oxidation is what they're asking us. So which one is the oxidizing agent? They undergo reduction, so this is the oxidizing agent because it undergoes reduction. So look for the option that has Mn in it. Look for the option that has Mn in it, and that should be your answer. But what did I tell you initially? Your answer is always found at the left. Always found at the left. So definitely this is the answer because it was found at the left. Do you understand? Your answer is going to be between the left hand side. Do you understand what's happening? It's very simple. So the answer to this question becomes option B. I believe you understand how it was gotten. Not this, because this was found at the right. The ones, I know we related them together, but the ones that are found the left is your answer to the question. It's very simple. All right, I'm going to give you a practice question to master this aspect of chemistry very well. It's very simple. All right, so let's progress. And let me give you a practice question before we go over to the question number 3. So if you find my video lesson helpful, make sure you subscribe to my channel. Make sure you share these videos to your friends. As earlier said, this video to get thousands of views. Make sure you get thousands and more thousands of subscribers, all right? So make sure you share my videos to your friends. So let me give you a practice question before we go over to the question number 3 and analyze more other questions, all right? Okay, guys, here are your own practice questions. They are simple. You don't have to be scared. Maybe you are seeing different numbers, plus. I told you don't have business with any number you are seeing here. I told you if you have to determine reducing and oxidizing agent, because what you have to do for me is to get the reducing and the oxidizing agent, you will look at your left hand side, only your left hand side, and try to relate it to whatever you have in your product. And in those guys, in these ones with charges, with H plus, you don't need these things. So you don't really have business with that H plus here, relating with water, you don't have business. So what you're interested in is this relating with this and this in this first question. You calculate for manganese out, you remove manganese. You understand? And get for manganese here, iron, iron. You understand? It's simple. This is chromium. So you see, relate chromium and this chromium. And what do you do next here? You look for sulfur. So in summary, leave oxygen alone and look for and focus on the other elements apart from oxygen and even hydrogen to determine this aspect in all of these reactions that have charges in them. Listen, in these ones that have charges in them, I would advise you, for this question now, you can see that it has oxygen in most part of the compound. So you are relating this and this and this and this. Do you understand? So what you have to do for me here is to calculate for the oxidation number of sulfur here and look for the oxidation number of sulfur here. Remember, you're not having business with the numbers. I believe you are following it. It's simple. You don't have to get confused. It's simple. That's why I'm stressing on it. For this one, you can see your answer is going to be between these guys, this guy or this guy. You understand? So what you have to do here is simple. What you have to do first of all is to determine the oxidation number of oxygen here, determine the oxidation number of hydrogen here, determine the oxidation number of oxygen here. Hydrogen is standing alone, so the oxidation number becomes 0. Oxygen is standing alone, the oxidation number becomes 0 as well. So then you have to determine the oxidation number for both of them. You can do it. Let's say you make one constant in the sense that you calculate for the oxidation number for each of, like both of them individually. Let's say you already know this one that it is +1, So you can just put +1 here and calculate for the oxidation number of oxygen. Do you understand? So let's say you want to calculate for hydrogen now, put -2 here because you already know that oxygen is -2 and calculate for the oxidation number of hydrogen. So those two numbers you have, you put it down and relate. Hydrogen relating with this hydrogen, what happened? Oxygen relating with this oxygen, what's happening? Do you understand? That's what you should do. It's simple. But more videos will still be out on this aspect so you guys can master this concept of chemistry very easy. And it's very simple. There is a reason I'm stressing on this so that you don't make mistake when you are providing the answers in the comment section. I recap. You are relating manganese here. You have to solve for everything here as done earlier. You have to relate this guy and this guy. Alright. You have to relate this guy and this guy. We have business with these two guys. This one I have to just mix it. I don't have to add not water at the end, so you don't get confused. I have to do it so that you know that it's not always water is not really written at the end always in other cases. So you have to relate this guy and the one that has chromium in it, and you have to relate this guy and this guy. You have this guy business, you have this guy business. Do you understand? So this one I've explained it is simple. So in these two guys, what are you doing? You are calculating for the oxidation number of sulfur and look at the trend. What's happening? Was there a decrease or an increase? If there is a decrease, reduction, and you have to be the oxidizing agent. If there is an increase, it's going to be what now? Oxidation, then you are the reducing agent. You understand? It's very simple. So let's get into the question number 3 and analyze the question, and it's very, very simple. So make sure you click on the subscribe button to my channel and also share my videos to friends. All right, so let's progress to question number 3. Question number 3 says, which of the following is an acidic salt? Very simple. We have different types of salt. A very easy trick for you to know acidic salts is that acidic salts are salts that have hydrogen present in their compound. Are you there? There's presence of H in their compound. So that's how you get acidic salt. So you have to look at all of these options and look for the one that has H in it. Like, I know you can see H here as well, but the salt is going to be inorganic. Inorganic means that it's not organic. When you're organic, you see more carbons in yourself. This is another type of salt, but this is a salt formed from an organic acid. So for acidic salt, the presence of hydrogen, this is acidic salt. But I can actually teach you specifically how it was gotten. All right, let me explain it for you. Now, first of all, what is a salt? Listen carefully. A salt is a compound formed when all or parts of the replaceable hydrogen ion present in an acid. Now, let me make it simple for you. This is an acid. And this acid, if we are to break it, what do we have? Listen. Breaking it, we are getting two ions, H plus and Cl minus. Do you understand? And how do we form a salt? A salt is a compound formed. A salt is a compound formed when all or parts of the replaceable hydrogen ion, this hydrogen ion present in an acid, is replaced by a metal or an ammonium radical. Do you understand? So this is an acid. So for instance, I'm replacing this H plus with a metal. Leave ammonium alone. Let's replace the metal like sodium. So I'm removing this H plus and replacing it with metal, all right, with this metal Na, all right, sodium Na plus. So when I do that, I'm pushing H hydrogen away, H plus away. So when I do that, what am I having? I'm having Na plus and Cl minus. Do you understand what just occurred? So this is the salt formed. Do you understand? Because definitely plus means plus one, minus means minus one, and they are exchanging their charges for we to form the compound. So it's going to be what an Na, the one here come here, the one here goes here. So altogether it still remains NaCl. So this is the salt form. So a salt is a compound form when all or part of the H plus present in an acid is replaced by a metal or an ammonium ion. But I'm going to use metals to explain all of this for you. So I just explained generally what salts are, but I have to tell you specifically for acidic salt how we form acidic salt, because that was the salt mentioned. Do you understand? So what is an acidic salt? It is very easy. Just listen carefully. Let me explain acidic salt for you. There are some things you should know. For an acidic salt to be formed, all acidic salts are formed from acids that are dibasic or tribasic. You don't have to get confused. Monobasic acids can never form acidic salt. I will explain. Listen. This is why you have to listen carefully. We have examples of dibasic acids like the likes of H2SO4. This is a dibasic acid. And I told you monobasic acids. Why do we know there's a basic acid? When we break it, we are having H plus SO4 to minus. But for we to balance this reaction, there should be two here to make sure that it's two hydrogen. So since at the end of dissociating it, we have 2H plus, it is a dibasic acid. It has two hydrogen ion. So for this, when we break it, what are we having? We're having just one H plus Cl. And how many do we have here? One. So it is a monobasic acid. Monobasic acid can never form acidic salt, and I'm going to tell you why. So this is an acid. You understand? And I told you it's a dibasic acid specifically. So how do we now form a salt? How do we form acidic salt specifically? Now I want to explain this. How do we form acidic salt? Very simple. Listen. These are salts formed when parts. Please listen. You know, when I was defining salt generally, I said all or part of the H plus present in an acid is replaced by metal. But for acidic salt, it is only parts. That means the H plus present in that metal is not replaced fully by that metal. It's just part of it that is removed. This is what I mean. It's simple. So now let's wipe out this monobasic acid. Let's wipe out it. Oh, I would have done. Okay, let me wipe it out. I'll still say it again. So this guy now, how many H plus does it have? It has 2H plus. And what did I say for acidic salt? For an acidic salt to be formed, is it not part of the H plus will be replaced? So we have two of it. So I'm going to remove one. I'm going to replace it with a metal like sodium. So I'm going to remove it. I've removed it. So metal sodium is coming now. Do you understand what's happening? So this guy has replaced it. So this H plus is now here, making this sodium to enter. Do you understand? It has entered. So when sodium enters, what happens? Simple. So what becomes the compound we are getting? So here will now automatically become NaH. Do you understand? It's simple. It's not difficult. All right. NaH. Sodium NaH. And the SO4. All right. So SO4 still adding. But there are reasons to how this was gotten, but I'm just using general knowledge. NaHSO4. All right. So NaHSO4. What did we just form? Acidic salt. So I told you acidic salt, there's still presence of H in their compound. Do you understand? So if you observe, that's the answer. Option A. This is acidic salt. So if it was this normal salt like this normal acid, monobasic acid like HCl, breaking it, we have H plus and Cl minus. All right. So how many H plus is even present here? It's not just one. So even if we remove it, nothing will be left. Do you understand? So when we remove it and replace it with a metal like sodium, it is still a normal salt that will be formed. Because the definition of a salt is still definition for a normal salt, which is a type of salt. We have basic salt. Basic salts, they have OH present in their molecule. So if it was a basic salt, I'm going to see OH in it, not H. Not H. I believe you are following me. You understand? For basic salt. For double salt, there's presence of water of crystallization and also presence of two cations and one anions. When we solve more questions, I'm going to explain for double salt, but this is the concept of acid salt. I believe it's clear. It's very simple. All right, so let's get into the next practice questions. All right, so if you've not yet subscribed to my channel, make sure you click on the subscribe button to my channel and also share my videos to your friends. All right, so let us progress. Okay, guys, let's get into the next practice question. All right, and it says electrolysis occurs in a special vessel called, now electrolysis, it's basically a process used in electrochemistry that has to do with the passage of direct current through a compound, be it in solution or molten form. And this electrolysis, it occurs in a special vessel called the electrolytic cell. This must be noted. It is a special cell to which electrolysis occurs and is simply called the electrolytic cell. Are you there? So let's get into the next practice question, and it says, in an electrolytic cell, the cathode is, in an electrolytic cell, it is made up of two terminals, which are the anode and cathode. These anode cathodes are the terminals to which current passes, and they have their respective signs. Yeah, they have their respective signs. For cathode, in an electrolytic cell, it is negative. Please take note. It is negative. If they were asking us about the anode, it is simply positive. Do you understand? It's very simple. But now, next question says, in an electrochemical cell, the cathode is what? Wow, because electrolytic cell is different from electrochemical cell. Are you there? For in terms of, they still have the same terminals, which are cathode and anode, but now the signs differs. For cathode in electrochemical cell, it is direct opposite. Cathodes in electrochemical cell is positive, whereby anode in electrochemical cell is negative. Are you there? There are differences between these two cells, electrolytic and electrochemical cells. Are you there? So watch closely and listen carefully. There are other differences between these two cells. You can see these are one of the differences, the signs of the terminals, which are the anode and cathode. Like for electrolytic cell, they convert electrical energy to chemical energy. Electrochemical is direct opposite. They convert chemical energy back to electrical energy. Are you there? So all of these must be noted. In an electrolytic cell, they require current to function. But for electrochemical cells, they produce their own current. Are you there? And these are like the key differences between there. There are other differences. Electrolytic cell, these terminals are present in one compartment. Electrochemical cell, they are present in two compartments. Are you there? And these compartments found in this electrochemical cell are connected together by what we call a salt bridge. This must be noted. So let's get into the next question, and it says sodium hydroxide NOH is dash electrolyte. Electrolytes can be of two forms. We have strong electrolytes and weak electrolytes. Strong electrolytes like saying strong acids, all right? Strong electrolytes, the electrolytes that ionizes completely in a solution. And actually, just take note of this. For you to be a strong electrolyte, you'll be either a strong acid or a strong base. So now, sodium hydroxide is a strong base. So automatically, sodium hydroxide is a strong electrolyte. Do you understand? So this is a strong electrolyte. Please take note. If it was any strong acid, it's still going to be a strong electrolyte. Do you understand? It's very, very easy. It's not difficult. CH3COH is a weak acid normally now. That's ethanoic acid. CH3COH is a weak acid. So automatically is a weak electrolyte. Do you understand? So this is a weak electrolyte. All right. Anything that is strong acid, strong base, strong electrolyte. Weak acid, weak base, weak electrolyte. Do you understand? It's very simple. So if you find my lessons helpful, make sure you click on the subscribe button to my channel, share my videos to friends. So let's get into the next question, which says, electrolytes conduct electricity by means of what? Wow. Take note. Electrolytes conduct electricity by means of ions. Take note. This is how they conduct electricity. I did have full video lessons that explains the calculative aspects on electrolysis, and and as well as the theoretical aspect. All right, you see the video here on the screen, so make sure you search on these videos, all right, on my channel, so you can watch them and understand perfectly every single concept about electrolysis. Moving over, conductors conduct electricity by what? By means of electrons. Please don't confuse this. For electrolytes, they conduct electricity by means of ions. Conductors conduct electricity by means of electrons. Are you there? So you can see here that both electrolytes and both conductors, they both conduct electricity. But what you have to know here is that electrolytes conduct it by means of ions, and conductors conduct their own by means of, electrons. And another thing you must know here between them is that electrolytes, they conduct electricity only in one state of matter, and that state of matter is simply liquids. So for you to be an electrolyte, you only conduct electricity in liquid form. But for conductors, they conduct electricity in the three states of matter, be it solid, liquid, or gas. Are you there? So this must be noted. So let's get into the next question. And it says, alnico is an alloy made up of. Alnico is an alloy. Alnico is used for making permanent magnets. So from the word alnico, you can actually even get the components. It's simple. Al, ni, and co. Wow. Al, aluminium is one of them. Ni is nickel, and last is cobalt. So these are the elements to which alnico is made up of. But the base metal is aluminum, in the sense that the most important element here, like the most abundant element in alnico, is aluminum. But the three elements to which alnico is made up of is aluminum, nickel, and Co, which is cobalt. Not copper. Copper is Cu. Do you understand? All these must be noted. So let's get straight into the next question, and it says the positive subatomic particle in an atom is simply called the proton. Proton is the subatomic particle that has a positive charge. Electrons negative, neutrons neutral. So let's get into the next question, and it says laughing gas chemical formula is very simple. It is simply N2O, which is dinitrogen 1 oxide. It is pronounced as dinitrogen, all right, 1 oxide. There are reasons to why all of this is like this. For the dinitrogen, means that we have two nitrogen. You know, see N2, two nitrogen, and it is 1 oxide. This must be noted. So let's get into the next practice question, and it says metals are brittle. Is that true? That statement is false. Metals are hard but not brittle. You have to know what the word means, brittle. For a metal to be brittle, it means that metals easily break, and that is not true of metals. Metals does not break easily. So metals are hard, they are not brittle, so this is false. All right. So brass is an element, very false. Brass is a mixture. Brass is what? A mixture, but specifically a metallic mixture. You can see the word brass. Brass is a mixture that is made up of two elements, copper and as well as zinc. Are you there? We have the brother called bronze, all right? Bronze is also a mixture that is made up of copper and tin. Do you understand? So all these must be noted. They are not they are not elements, but rather they are mixtures. For duralumin is not a compound. So this statement is false. Duralumin is a mixture. It is made up of aluminium, right? It is made up of copper. It is made up of magnesium, and as well as manganese. These are the elements found in duralumin. It's an alloy that is used for making the body parts of airplanes, all right, and it's very light. So let's get straight into the next question, and it says P1V1 is equal to P2V2 represents dash gas law, simply called the Boyle's law. Take note, which was brought about by a man called Robert Boyce. All right, so let's get into the next question, and it says, does catalyst affect the rate of a reaction? Yes, catalyst does. Rate of reaction has to do with the speed to which that reaction goes into completion, and catalyst is one factor that actually affects the rate of a reaction. If there is a catalyst in a reaction, the rate to which that reaction will go into completion will be faster without the catalyst. So catalysts affect reaction, not just catalyst, even surface area affects reaction, even temperature affects the rate of a reaction. Are you there? So all this must be noted. So let's get into the next question, and it says, what is the catalyst used in contact process? Contact process is a process used to industrially form this compound, which is H2SO4, and the catalyst used is called vanadium 5 oxide, V2O5. Is pronounced as vanadium 5 oxide. So let's get into the next question, and it says, what is the catalyst used in Haber's process? Haber process is a process used for formation of ammonia, NH3, and the catalyst is finely divided ion. Finely divided ion, this must be noted. Alright, ion that is finely divided, ion that is already matched to increase the surface area. So when that ion is actually finely divided ion is used as a catalyst in Haber process, the rate to which ammonia will be formed will be very fast. So this must be noted. Calculate the oxidation number of calcium in this. You have to do that for me. We are looking for calcium, so solve this for me. Simple. I believe you already know the oxidation number of oxygen in most states. I believe you already know the oxidation number of hydrogen in most states. I told you, rewrite it and make it easy for yourself. Comment down the answer in the comment section. All right, let's get into the next question, and it says, the allotrope, specifically the crystalline allotrope of carbon that is very radioactive, is simply called graphite. Remember, on the crystalline allotrope, we have two major allotropes, which are diamond and graphite. Graphite is the one that is very reactive. Diamonds, they are inert. Why are graphite reactive? They are reactive due to the presence of mobile electrons in their structure. They are electrons that moves, so that is why they are very reactive. Are you there? So let's get into the next question, and it says, the coal mainly found in Nigeria, what's it called? It's called lignite. Lignite is the coal that is mainly found in Nigeria, and lignite is also called brown coal. This must be noted. Are you there? So let's get into the next practice question. If you find my video lesson helpful, make sure you click on the subscribe button to my channel. Also share my videos to your friends, alright? So let's get into the next question. Okay guys, let's get into the next practice question, and it says, what is coagulation in water treatment? This question is extremely very easy. We have different steps in water purification, water treatment, and one of them is coagulation. They're not asking, what is coagulation in water treatment? In coagulation, a compound is used called alum. All right, so it's basically it's a process that has to do with all of those impurities found in that water that is to be treated clumps together. So when those impurities clumps together, that is called coagulation with the help of what? Alum. Are you there? So that is for that. So let's get into question number 25, and it says, acids have bitter taste. Is that true? Very false. Acids have sour taste. It is bases that have bitter taste. Are you there? So let's get into the next question, and it says, concentrated form of acids are corrosive. Very true. Concentrated form of acids are what? Corrosive. So let's get into the next question, and it says, how is oxonium ion formed? Very easy. It is formed by reacting hydrogen ion with water. Do you understand? When this happens, we are getting H. We have 3H now, so it's going to be H3O. The plus has added everything together. So H3O plus, that is called oxonium ion or hydronium ion. Are you there? So this must be noted. Let's get into the next practice question, and it says, S orbital is dashed in shape. You must understand here that S orbital is spherical in shape. It is spherical in shape like this. All right, you can see it. Whereby for the p orbital, it is dumbbell in shape. It is dumbbell in shape, yeah. And dumbbell shape is like this. Do you understand? That's for the p orbital. Orbitals basically, they are found in an atom. You understand? And we have different orbitals, which include the s orbital, the p, the d, the f, the g, h orbital. They have their respective shapes, which I'm telling you right now. It's very important. For the d orbital, it is double dumbbell. It is double dumbbell in shape. All right, so it's like double of this thing I just drew. One of it, another will actually go like this. Do you understand? Double dumbbell shape. Moving over to the next question. If it's for f orbital, from f orbital down to the h orbital, they are all complex in shape. Their shapes are complex. All right. So let's get into the next practice question. And the question says, air is not a mixture. That is false. Air is a mixture of gases. It is made up of oxygen, which is about 21%, nitrogen 78%, carbon dioxide CO2 0.03%. Noble gases very small in percentage. Do you understand? So all this must be noted. Air is a mixture of gases, so air is a mixture. The process whereby a substance changes from solid to gaseous state, what's that? It's called sublimation. Do you understand? For instance, camphor can sublime. I believe you are following me. So next question says gas particles undergoes dash motion. Gas particles undergo random motion, or we call it zigzag motion, or you call it Brownian motion. Are you there? So this must be noted. So on the basis of electron, what is oxidation and reduction? For we to define that, I'll use this acronym OYERIC. All right. Oxidation is loss of electron. Reduction is gain of electron. Do you understand? So oxidation is loss of electron, whereby reduction is gain of what? Electron. The G here means gain. The L here means what? Loss. I believe you are following. Is very simple. Question number next is the energy used to split up ions in crystals to fill them is called lattice energy. Take note. They call it lattice energy. Energy required to split up ions in crystals is called lattice energy. Please note this is very important. The next question says, when delta H in a reaction is less than 0, what does that mean? These questions are technical and very simple, so listen carefully. Now, you can see that this question is from spontaneity of a chemical reaction. Are you there? Now, whenever we just see H, we simply call it enthalpy. Are you there? But when there is delta, it's called enthalpy change. And what's this enthalpy change? It's simply the heat change that accompanies the chemical reaction. H itself, enthalpy is the heat content of a reaction. And this delta H or enthalpy can be either positive or negative. When delta H in a reaction is positive, it tells us that that reaction is endothermic. What does an endothermic reaction mean? It means that it's a reaction that absorbs heat. Do you understand? But when it's negative, it's exothermic. It's a reaction, exothermic reaction are reactions that give off heat to the surrounding. Now, they're not asking us, delta H here in this reaction is less than 0. Simple now. It's just common concepts, all right? We have what we call number line, the number line system. Numbers that are, 0 downward, less than 0, what are those numbers? They are negative. Whereby numbers that are above 0, what are those numbers? They are positive. Do you understand? So this number is less than 0. So definitely this thing that is less than 0 still means saying that delta H is negative. Do you understand? So when delta H is negative, what becomes that reaction? Will it be endo or exo? It's going to be exothermic. Do you understand? It's very, very simple. So let's get into the next question. It says, when delta H in a reaction is greater than 0, when you are greater than 0, you are positive. Do you understand? In the number line system, you get, so when you are greater than 0, it means that delta H as well in this reaction is positive. So as well, this reaction is endothermic. All right, it's endothermic reaction. It's an endothermic reaction. So let's get into the next practice question, and it says the chemical formula of cryolites is this: Na3AlF6. All right, just take note of it. The chemical formula for cryolites is what I just wrote: Na3AlF6. All right, so moving over to the last question, which says the measure of the degree of disorderliness in a reaction is called entropy. Take note. Entropy, enthalpy, they are all, they are all parts, they are all, what do you call it now? They are all state functions that determines if a reaction will be spontaneous or not. In subsequent videos, I'm going to explain more on the concept of spontaneity of a chemical reaction, so you understand perfectly about enthalpy, entropy. Enthalpy is symbolized as H, entropy is symbolized as S. So when I put delta, when I put change in them now, it's going to be delta H, delta S. So change in enthalpy and change in entropy. There are key concepts on this. I've solved so many questions on this aspect as well. So go check more of my video lessons here on my channel. So we've come to the end of this video lesson. If you find my video lesson helpful, make sure you click on the subscribe button to my channel and also share my videos to friends. Thanks for watching.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAMB exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.